All right, how are you? This is the measures of central tendency and dispersion or variability lecture, and it's for week 3. And the beginning of the lecture will cover chapter 3, which is on central tendency, and the second part of the lecture will cover chapter 4, which is on variance. Okay, so let's get started. The first thing that we want to talk about is what is central tendency? And as Graviter and Wallnow tell us, it's a statistical measure to determine a single score that defines the center of a distribution. You remember a distribution, when we look at a curve, a distribution is a collection of scores that define that curve. So the goal of central tendency is to find the single score that's most typical or most representative of the entire group. And let's take a look at why central tendency might be difficult to define. This is a normal curve. So we could see pretty much that most of the scores or the mode are right here in the middle. Most of them 1, 2, 3, 4, or 5. So in this one, the mean and the mode, the average and the mode, are the same. Again, don't forget this axis is the frequency, and this axis are the x's or the scores. Okay, in this one, it's kind of hard to define these, because where's the center of this? I'm looking at this. This one's real easy to tell, but this one is hard to tell the center on. Or what about this bimodal distribution? When we have two chunks and nothing in the middle, we have a chunk here and a chunk here, but there's nothing in the middle. So how do I define what the center of this is? Well, it's harder. So let's pop over to the next slide and discuss for a minute the average or the mean. All right, and let me just, I want to get my pen on the, having a little trouble getting my pen over on the other screen here tonight, so I don't know how I'm going to show you or draw on the screen. Let me just put this on hold for a moment. All right, it's going to be back to the drawing board on the tablet, because I can't get it over to the right screen tonight. So you'll just have to bear with my mouse pointer. So the mean is equal to the sum of all observations divided by the number of observations. Okay, and remember the number of observations was n, the letter n, as in Nancy, and the sum of all observations was sigma, that big, this mark here, the Greek letter sigma. So the sum of all x's in a sample, we use the small n, and in a population, we use the large N to describe the number of observations. So if we are asking a researcher how many people they had in the experiment, he might say that they had an N of 200. That's the way that is used. And often the mean is not an actual data value. In other words, American families here could have an average of 1.2 children. So it doesn't have to be a real like 1 or 2 number. And let's pop over to the next, the definition. Did I go the wrong way? Yes, I did. Let's see if we get down here. I'm having a little trouble here tonight. I'm going to pop back to so we talked about the goal of central tendencies to find a single score. Going forward, the the symbols for the mean in the sample and in the population. The population size is equal to a large N. The sample size is equal to a small n. The population mean is the Greek letter mu, which is kind of a fancy looking M, mu. And the sample mean is an X bar, or large M. This is the symbol for X bar. You can see right down here. And so the population mean, mu equals, don't forget, the large N is the population size. So the mean is equal to the sum of all the x's divided by the large N, or the number of observations. And the sample mean is X bar instead of mu, because don't forget we're using we could also use the large letter M here, equal to the sum of all x's divided by the sample number of observations. Okay, so it's just a matter of, you're either going to be working with a sample or a population. You won't be working with two of them at the same time. So you'll either be using a large letter N or a small letter N. Don't worry about mixing them up. Popping over to the next page. Let's find the mean. Okay, so observation A had 10. Observation B had 9. Observation C had 12, D had 8, E had 11. So if we add them all up, the sum of x is 50. And to find the mean, we simply take the sum of x and divide it by n. So it's 50 divided by 1, 2, 3, 4, 5 equals 10. All right, so 50 divided by 5 equals 10. That's the mean, or the average. Other characteristics of the mean. Changing a single score in the sample will change the mean. Adding or removing a score will change the mean. If adding or subtracting a constant from every score, the same constant will also be added or subtracted from the mean. So in other words, a constant is let's say I added 2 to every score, well, that would also be reflected in the mean. And 4, if multiplying or dividing each score by a constant, the sample mean will